Okay, try this guy. How about find the area? Again, I'm just getting used to the notation here. That's an ugly looking R. It's supposed to be an R. The area R, so let me make sure we understand what R is. R is this region right here. Okay, that's all it is. Find the area, R, I guess R is not the area of R, whoa, of R, and these get awful with this tablet, sorry, bounded by, let's go f of x equals x squared, and let's do g of x equals 2x minus x squared. Now, I'm going to do this without visualizing the functions at first, because that's a really good exercise to do. It gets really tricky if you don't know what the functions look like, if you're trying to sketch the region, if the functions are nasty and you're struggling with them, then that can be really hard. But let's just do it from a strictly algebraic standpoint, okay? First thing I need to do is I need to know where the action takes place, right? I need to know what this region is that we're bounded by. So I should probably figure out where they intersect. So first thing I'm going to do is set f equal to g, which gives me x squared equals 2x minus x squared. So I get 2x squared minus 2x equals 0. Factor out a 2x, and I end up with x minus 1 equals 0. So I have my intersections are at 0 and 1. Now, let's check who's bigger. Who's bigger? Now, clearly, we know what these look like. They're both parabolas. I can already visualize, but let's assume that we didn't know who's bigger. I think it's who is bigger, right? Whose is this? Who, sorry guys, too much caffeine. Who is bigger? On where? On what interval? Well, it's got to be the interval from 0 to 1, right? I don't have a choice because I don't have any other intersection points. So this can only be bounded between 0 and 1. Now we will look at the graph here in just a little bit. And remember, you have your graphing calculator to check these things out. But I do want you to understand the process that we're looking at. So let's look at, how about x equals 1/2? Okay? So f of 1/2 is just equal to 1/4 or 1/2 squared, right? And g of 1/2 is equal to 2 times 1/2 minus 1/2 squared, affectionately known as 1 minus a fourth, which is 3/4. True? So it appears that g is our winner. So if I'm trying to find the area is exactly equal to the integral from 0 to 1. We know there are no other places where these things cross, or I would have ended up with more solutions. This is the integral from 0 to 1 of g of x is bigger on the interval, so it's 2x minus x squared minus, right, I'm subtracting out the height, minus x squared dx. And this ends up being the integral from 0 to 1 of 2x minus 2x squared dx. And that's it. I can do these integrals really easy. Notice how I just sort of left them. And I will ask that you do them by hand, but I'm not going to insult you by doing them by hand in front of you, right? You can always check them with your calculator, but you do have to be able to do them by hand. I suppose maybe I should do, oh, what the heck, I'll do one by hand, right? So I got x squared minus 2/3 x cubed from 0 to 1. This is actually a pretty easy one. I kind of wimped out. This is going to be 1 squared minus 2/3 of 1 cubed minus 0, right? So this is equal to 1 minus 2/3, affectionately known as 1/3. Yay! Now, let's be real clear on something. Think geometrically. What is area? Area is always, always, always positive. Remember, integrals are allowed to be negative, right? If I were to integrate y equals x squared minus 2 from here to, say, here, I would get a negative integral because the area lives underneath the function more, right? But don't think of it as area. Think of it as f of x. The height of those rectangles are negative when I'm integrating in that spot. Well, they're more negative than they are positive, right? If I'm trying to find the area between, let's scoot over, and I've got a picture that's all crazy. If I'm trying to take the integral If I'm simply integrating, let's take this function, I'm just going to call it f of x, and I'm going to integrate from 0 to a, right? I know that the integral from 0 to a of f of x dx is less than 0. It's negative because the height of my rectangles, that f of x part, that should be right there, is negative, right? Remember that? Integrals are allowed to be negative. However, area is not. We are finding area. We're using integrals to find area. So if you end up with a negative area, something has gone horribly wrong. You probably ended up flipping these values. You ended up flipping these two functions, and that'll give you a negative. That's often what happens. Okay, so remember, integral doesn't necessarily equal area, especially in the geometric context. Now let's look at these two functions real quick and see if we can figure out why we did what we did. What did we have? We had f of x, I think, equal to x squared, and g of x equaled 2x minus x squared. If I do a quick little sketch of these graphs, I know that y equals x squared looks like that. Now think about this. This is a parabola. It's upside down parabola because I got a negative there. I know it's got x-intercepts. I'm doing this quickly in my head. If I set it equal to 0, I'll get 1 at x equals 0, and I'll get 1 at x equals 2. So I know this guy goes like that. Remember, these guys ran into each other at 0 and at 1, right? So what I just found was that area right there. And how did I find it? I built myself a little sliver of area. All right, and the height of that, it was this guy minus that guy. The width of that was delta x. All right, we're going to do one more where we've got some crazy looking functions, and I'll see you back here in just a sec. The bell just rang, so I'm going to hit pause, as it were.